Baby, you're not too bad. Alright, welcome to the stream. We just started. I'm just making sure everything is working good. It looks like it is. Too bad. Yep, that's working. It's definitely working. Alright, so, anyways, welcome to the stream. So, I'm just gonna finish up these instructions. As the description says, I'm gonna finish them up, and then I'm actually going to start with the disassembler, which shouldn't be hard because all these are sort of like already implied and they have strings, and so strings help with the disassembly. So that shouldn't be too bad. I could probably just create a new class like this. And so yeah. Anyways, let's continue where we left off, which was we just kind of put these in action. We really didn't do anything with them. So that's gonna be what we're gonna be doing today. So let's go to the last instructions. I also didn't comment anything yet because I wanted to get the instructions done before I started commenting. So it's actually so decimal just register A. So I still have no idea what that means. I can Google it. I probably won't. Let's just work on this one. So we got halt, stop, and then disable and enable interrupts. And so that's probably going to be I'm probably going to do this in the CPU. So a couple of them is going to be like they're going to be booleans, and they're going to be interrupt disabled, and that's going to be false. I should probably put this in here, and then there we go. So interrupt disabled, and then we need halt and stop. So hey Dinnick, how's it going? So yeah, it's been going pretty good. I've live streamed earlier, so hopefully other people can see what's happening. So anyways, let's continue on. So we also need halted. So we need CPU on and screen on. So, and then these are going to be set to false as well. So CPU on is equal to true, because if it's set to false when we start, then how the frick are we going to start? Pretty good. What about yourself? I mean, and I just woke up. I got like not a couple minutes ago, but like 30 minutes ago. And I was just like, yep, I'm going to live stream. And so here we are. And screen on is going to be also set to true because it's off at first. Yeah. So yeah, these aren't used because we actually have to get some getters and setters. So let's do that. Source, generate getters and setters, select all, or actually just deselect all and just click the ones CPU interrupt and screen on. So there we go. So is screen on, is CPU on, and is interrupt disabled. And then we can set interrupt disabled, all this, and then all this other stuff, and the opcodes. So now with this, we can say CPU.interrupt is set interrupt dot set interrupt disabled, and then that's just going to be set to whatever on is. Yeah, same. Shouldn't you make a separate class for screen on called GPU for rendering? I think that's gonna like I haven't gotten to anything rendering yet, and I think I'm just gonna have that one flag for the CPU, and then the GPU can actually read that, or because the CPU can't. The CPU should access the GPU. The CPU should access everything, but it just doesn't, because I made the Gameboy that access everything class. So I mean that's probably not good. I just haven't gotten anything into rendering yet, because I just wanted the CPU to be done. But I know interrupt should be in the CPU, and of course the CPU, like whether or not it should be on or off, should be in the CPU. So I at least got 3 out of 4 right. Hey Lawrence, welcome back. So how's it going? You were here yesterday talking to me. So let's continue on with that. So stop is turning this the CPU on as well. So CPU dot set CPU on. That's going to be equal to false, and then CPU dot set screen on is also equal to false. Okay, that makes sense. Is it going to be open source later? I mean, yeah, it's going to be open source. It's just I need to get something there. I need to at least have a CPU there. I'm not just going to keep open sourcing an incomplete CPU, because that just doesn't make sense. Like, at each step of the way, I'll probably upload it to GitHub. So yeah, so CPU halt is just stopping the CPU, and that's it. So set CPU on right there, just equal to false. And then this is the one I don't know about, the decimal. It's pretty good seeing the progress. Yeah, we made a lot of progress yesterday. We got most of the instructions in. We just need jumps and bit stuff, and that should be it for the instructions. And then we also need to get timing down, but then I'm going to actually work on that a little bit later, to where I just want to see a disassembled like boot screen, because I know timing is pretty important, but I'm just trying to test this. So anyways, let's continue on. So decimal adjust register A. I'm going to go here, decimal adjust register A. Is that a new one? This is a new one. Control find DAA. There. It's not really a new one. Decimal adjust register A. Let's search it up. Maybe this knowledge base. Just trying to see what this is. Auxiliary carry flag. Well, we don't have an auxiliary carry flag. We just have a normal. Man, this is confusing. Gameboy DAA. There it is. Thank you for perfectly describing how I'm feeling. Eric Haskins. Set background. One last CPU instructions I have left is DA. I can't find it. Binary coded decimal. I've heard this before. I have no idea what it means, so let's read what it means. So 1, this is 10. Originally, sometimes we encode each decimal digit into binary. We call this separate encoding binary coded decimal. So this is 1, this is 10 for some reason. I don't know why. This is 99. This is 1, 10, 32. Oh, okay, I see what you mean. I see what it is now. So instead of coding it like this binary, like the normal binary, how we would normally do it, we would code it like this, and then it still has the same basic like 0 to 255. However, it's just not really organized well. So this is the tens digit, and this is the ones digit. Or wait, it can only go up to 9. It's kind of stupid, actually. Oh well. Look at a simple case. Okay, so if the sum is greater, if the sum in greater, nice typo right there, the 9 add 6. So is there any other rules? Oh shoot, I didn't subtract like that, like I actually subtracted. Ooh, that's not, I didn't do that right. 2, 8, for all the bits, and add 1, and that's... Is it to run immediately after the... This is, yeah, it is confusing, you're right. So the DAA instruction is to run after the addition or subtraction, and then if it was BCD encoded. One if there, okay, so we got those flags. I know we got those flags because I did those flags. So if adding, add 6. Subtracting. Oh shoot, code, I don't want to see that code. So okay, it's not as confusing. I don't have to worry about I don't have to convert anything to binary coded decimal. All I need to worry about is how to fix, how to convert from either ones. This makes absolutely no sense what you think about it. You're making it load so much more to memory for some reason. I don't know either. I think it's for human readability, but even then, you have a hex editor. Most people have a hex editor to create your games with, and so once you get like good in the hex that like you can convert from either ones, I don't understand why you would use this, but apparently it's a thing, and I have to implement it to have an emulator. So if adding, so thank you. I think this is all we need. This is all we need basically. So well, we don't have to do anything adding or subtracting. All we have to do is fix it. Yeah, that's the wrong one. This one. So if adding, Alright, so we add 6 if it was carried or each digit is greater than 9. So if it's for physical electronics, makes sense. Anyways, so if, let's say if CPU.get, we gotta see if the carry flag is enabled. So if there was a carry slot, get flag PSW register dot carry flag. So if the carry flag is enabled because we have to add or subtract depending on it. And then why load 3 values into memory when you could load 1 value? Yeah, I don't know either. Binary code decimal or BCD is a way of representing a decimal number as a string of bits suitable for use for electronic systems. So it's just so I don't know. Well, why can't you optimize it for modern day systems? No, I understand how BCD works. It's just that why? Why would you use it? I don't know. I'm just gonna do whatever this instruction is and get on with it. So, anyways, so if the carry flag is enabled, we have to see whether or not it's an addition. I think we should do that. Like, if CPU dot get register or get register PSW dot get flag. We need to do PSW register dot subtraction flag or subtract flag. Few Guthix, yeah. BCD is weird. To make decoding for screens and GPUs easier. Alright. I guess that makes sense. So also hi Phil Guthix, welcome to stream. If you've been here, if you haven't been here, I mean, if you have been here, well, hi. And as each character will always be 4 binary digits. Yeah, and then it makes things weird because, you know, decimal only goes from 0 to 9, and then you have the rest of those digits that aren't being used, like the article said. It's weird. So if the subtract flag is, that means it was a subtraction. If it wasn't, it was an addition. And so that's how we know whether or not. And then if it was carried, when it was subtraction, we subtract 6. Yeah, alright. Then we just do this dot set register, and since A is the only math register, that's basically what we're going to be doing. And then we have to set it to that register minus 6. So get register A minus 6. And then there's other ones, and if subtract, but it's each digit too. I'm just gonna look at the code. Oh shoot, why? Well, I don't think we need to be doing this. Let correction, so set flag equals 0. If flag H or not flag and greater than. Yeah, well, that's even more confusing. That made me even more confused looking at it. I'm just gonna do it my own way. I gotta go back up to the rules. So, that was really weird. But our modern day system can handle this way faster, and this is only meant to run on systems with Java installed, so why wouldn't you get away with the standard binary form? Well, it's because the Gameboy emulator, apparently some developers use this. Hold on. Games that used BCD and Gameboy. So, something about the DAA opcode is here. He is emulating. Okay. Alright, so that's weird. So it only seems to support 8-bit numbers, and if you have a 16-bit, well, that didn't help as much as I thought it would, but oh well. Anyways, so let's just continue on. So if it was carried, then we need to subtract 6 from each digit as in the each 4-bit number. So if CPU.getRegister, that's the carry flag, we need to go through each one. And since this was an 8-bit number, or wait, it can't be, it might be a freaking, no, it's the most it can be is a 12-bit number, because for BCD, oh, okay, I thought you were going to use it for stand-up system instructions for CPU and GPU, and I was confused. Well, it's just, yeah, emulators, like the old stuff they do is really weird, but we have to do it, so. Anyways, so this sets the register to that, and I think we just got to set each of the 4 bits, and the most it goes up to is 12 bits, because it's a 3-digit number, 255. Alright. Except the first one will never be over. Yeah. This is confusing. So I'm gonna do something I probably should never do. Game Boy emulator, open source. I am going to see what other Game Boy emulators have done with this. That's Game Boy emulator. Let's just look through the entirety of GitHub. I know this is cheating, and I would never do this. I never like this, but this is just so confusing to me. Multi-platform Game Boy Color, Game Boy Advance. Thank you. Something that's written in my language too. So source, the actual thing, CPU, opcodes, oh, this is not fun. This is definitely not fun. He did it a whole different way. Alright, so I'm looking for, what am I looking for again? I'm looking for DAA. Where's DAA? Here's DAA. We gotta look for DAA somewhere else. Where is that? Alright, so load A. Alright. Doesn't really help me. I just had a little issue right there. That's not cool. Alright, so how does this even like work? That's what I'm trying to figure out. It's like, how does this work? So apparently it loads the instruction. It does. Maybe it's like somewhere in like a different class. This is really weird. Yeah, this could help. This can definitely help. So DAA, where is that? These are rotating stuff. DAA. Here we are. Oh shoot. Yeah. Yeah, I'm just going to put this in a comment so I don't have to keep looking at that. Oh shoot. There we go. Alright, so now that's a comment. I can look at this. So it gets the result, whatever, it's probably whatever's an A, to be honest with you. And then if it's negative, aka if it's subtracted, which I did here, and then if it does a carry, it does, yeah, it's checking for both, and then it sets a half carry to false. If it's greater than, set the carry to true. Set whatever the thing is there, and then see if the zero flag is set. Alright, yeah, alright, that makes sense. Gotcha. Okay, alright. So I have to do the half carry flag here, so half carry. I was almost right. So oh, we also got to check for overflows or underflows in this case. I'm gonna do it like I normally do it because that's how I normally do it. That's signed by wrong one. Where is it? Here we go. Boom, 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 boom. Alright, so then we need to say int subtraction is equal to this get register -6. You go to this, and if it's less than 0, you add it, and then set subtraction. Okay. So that's just a really weird way of doing this. I'm gonna actually get out of here now. And so, yeah, all right. So if the half carry flag was set, then we want to subtract 6 from that bit. And then if the carry flag was set, so basically the same thing, but for the upper bit, because that's what happens. So if the carry flag was set, what is 60 in hexadecimal? That is 6 times 16, which is 96. So x 60 to decimal. 96, alright. So I was right. So that's cool. So you subtract 96 from this, because that's the first, you subtract 6 from the first byte, or the most significant byte basically. You check if there's an underflow, and then you set the register to that one. Alright. And so that is the negative, and then basically we do the same thing, but for addition, and then we have to set a few flags. And yeah, so if there's a, oop, what the heck happened here? Oh, I did the wrong one. I did like this. So we have to add 6 and result. Wait, this is different. So if it's the half carry flag, or the this dot get register A. So this dot get register A, and the first bit of that, so 0xf, we gotta put those in parentheses. Hopefully the rest of the instructions today are not as confusing. Then we just do, you just add. And then then we just call this addition, just to make it, seem right. And then we can check for an overflow. And then right here, result. So if this dot get register of A, And that checks it all, and then we have to set a few flags. Alright, so I'm actually going to grab our trustworthy. Is that the right term? I don't know if that's the right term. Our useful little setting flags, and actually did I get rid of the article? I did get rid of the article. Dang it. So it resets the half carry flag, so that's false. What else does it do? If it's an overflow, so if this dot get register of A is greater than 2 to 5, then that sets the carry flag, the overflow flag, and then we need to set if this dot get register is equal to 0. Is equal to 0, and then the subtract flag. Is that involved anyway? No. So the subtract flag is not affected. And then we need to check for overflow. So there we go. Overflow is right here. And that sets that. And this actually needs to be the start register. And yeah. Alright, I am back. I had to deal with some family, and there's a fly on my wall. There we go, got it. Anyways, so let's continue on. So we have to get the register, so this dot get register A. If it's greater than 55, then we need to set it to that minus 256. So set register, register A, and then this dot get register of register A minus 256. And that is how we do the DAA instruction. Thank you, Coffee GB or whatever. Mm-hmm. Anyways, so I am going to continue on with the other instructions. So I am just going to, where is this? And whoa, what was that? I saw a bunch of X's. Is it that why I missed the X's? I'm just going to scroll by slowly. Here we are. What is this? The board on the time map is downloaded in a G20. Okay. The regular GB screen fits in the middle, right like this. Alright, so that's actually for the SNES. It's not for me. So that is good. Yeah, here we are. We're in the instructions again. So, yeah, it's fine. I just got error on my live stream saying, oh, it's too much. Oh, it's too much. Alright, so are we ready to do these CB instructions? No, I'm not, because we have a few that aren't CB instructions. We have rotates and rotates the other way. Alright. So hold on. Sorry about that. Anyways, let's continue on. So we are on our last four. It would be like rotate, like bit stuff. I thought that'd be in CB, but it isn't. So let's just do it. So public void, and what is it called? That's the live stream. Rotate left carry A. So it rotates the accumulator left. So let's do that. I'll just do rotate left accumulator and then a boolean carry, and then do the other way too. So we got rotate left, and this is just what it does. So it just rotates left. All right. So what is the new bit though? So it rotates left, but then there's a new one. Is it just 0? Oh yeah, it's 0 because rotate A left through carry flag, like in carry the carry flag is gonna hold the other instruction. So so this is going to be set to false because I don't want the carry instruction to be there. And then the other one is going to be set to true because I do want the carry to be there. If you, I mean, yeah, if you know what I'm saying. So this dot not really set register. We have to create a variable. Alright, I am back. Most of this live stream is just me being, hold on, I'm back. Hold on, I'm back. So I don't want that anymore. I'm going to try to keep it constant and actually get the instructions done. Because at this rate, we're not going to get the instructions done. So anyways, we need to rotate the accumulator, yeah, that's the right register name, to the left 1 bit. So that's pretty simple. All we need to do is say shifted is equal to this dot get register, the A register, shifted to the left one. Um, it never stops, does it? Me being gone. It's just kind of, So hopefully it's all worked out and we can finally get it, get this done. So, anyways, we're rotating to the left. That means we're going to shift it and we're going to put the old bit data. Does rotate mean that? I really want to know. Rotate bits. Game Boy. Game Boy. Here we go, here we go. Clarification about flags affected by rotate instructions. And so hopefully this can actually clear up what the frick are we doing. Also, it doesn't look like I have good internet. I can see that right here on my screen. Alright, so Alright. That's just making me more confused. He's just saying that pull it from a source code and it doesn't exist. So I am actually going to go to GitHub again. Maybe that coffee, github.com. Oh shoot, this is my GitHub. Oh shoot, people like me. Oh my goodness. GitHub, coffee. Where is it? I've done it before. Coffee. Here it is. Opcodes. Alright, so what is this? Is it rotate? It is rotate, right? Rotate, wherever that shall be. Rotate left A. Oh, it's not. That's not there. It's weird. Oh, here it is. So rotate left, rotate right, rotate, and so all this. Auto get value. It'll load the get value. It's another accumulator instruction. I went too far. So CPU accumulator function. And so it's another one of these. Here it is. All right, so it shifts it and then takes it. So if 1 is not equal to 0, then result is 1, and it's set. If it's not, then set to false. Okay, so it is. Okay, I see what this is. So it is what I was thinking, that it just gets rid of it and it is 0. It is not actually rotated, it just is 0. Okay, so it's shifted to the left, and so this is rotate left, and so if it's not without carry, so if we also need to set the carry flag to whatever the new shifted is. So if shifted, it's shifted over. If shifted right 8 times, I have to put that in a bracket, is equal to 1, aka if a bit got shifted over to where 1 is now in there, then we need to actually set the carry flag. So CPU.get register the program's status word, and then we need to say set flag, and we're going to set the carry flag. So dot carry flag to on, so true. And then we need, that will be it for this one. And then if shifted, or not if shifted, if carry, that means we actually have to add 1 to the end of it. So if carry shifted, and then you can actually combine with or. So what this should do is it shifts it to the left, and then if it is shifted to where it has a 9 bits now, and the carry flag is set, and if we should actually do this before, because then no matter what, it will always do the carry flag. And then so now the carry flag is set, and then if the oh wait, no, we can't do, this is the wrong one. This has to be .get flag, and we have to put that in. Since it returns a boolean, we have to use this term. We have to use our little question mark colon little looking thing. So question mark 1, it's not, and 0. And so now we can actually say if shifted shifted is greater than 255, then we override it. Shifted minus equals 256. And then finally we could say this dot set register A with the shifted. And there we go. So that is how we do right left. So anyways, let's go into wrong one. We have to go to the CPU manual and we have to see which are affected. So it looks like it's 07 or 07, not 007, 07 and 17. So let's just me checking my phone. Let's go all the way back up to our big switch statement, and we need to say case 0x07. Then we need to say this dot rotate left A, and wait, is this with the carry? No, it is not. So this one is false. And then break, and then 0x0 or 17. This dot rotate left A, but true this time because we need to use the carry flag as the new bit. And then we got to do the same thing for, I guess, these other ones. These rotate right and then rotate left. Oh, we forgot the zero flag. The zero flag. The zero flag. Oh, we have to go all the way down. Complement. Rotate left. All right. So if so, this sets the carry flag, and then we also need to. We also have to reset these other flags as well. Crap. So it is a case of resetting all the flags, so boom. So what are the reset flags? So it looks like the half carry flag is reset, so false. And it looks like the subtract flag, but if shifted is equal to 0, and if the carry flag is already set. We already set the carry flag with the if statement, so we can, that's already done. Then we get the half carry, the 0 flag, and the other one. Hold on, I'm going to take a text message, so if I'm quiet for a little bit. Hey Trade, how's it going? I'm just going to take a text message right quick. Hold on. Why is my time like that? It says it's 3 o'clock on my phone, but it's not. It's 1 o'clock. It's almost 1 o'clock. And almost 3 o'clock, I meant. So date and time set automatically. Yeah. So, anyways, let's continue on. So now that we have the right, we can basically copy and paste this and say, let's go, or we got the left, we need to say we need to go to the right now. And it's just not really as simple as just flipping these two, the greater than signs, or the less than signs in this case, and then now it's the greater than. So now the problem is that the byte is gone. And I don't know how to get that next one. So it shifts it, and then it needs to put whatever. So sets the result of 0. Well, not that. I wanted to see. Okay, so this needs to be put and then shifted to the left 7 times. So that's how we can do this new carry flag, but I don't know how we do the carry flag here. Oh, I also realized that if it's not, we can also just do, once again, optimization sort of is not equal to 0. So if it's not equal to 0, it is true. So there we go. Yeah, we got the set flags. We have all this, and so now we can do the same thing here. The problem is I don't know how we are going to detect whether or not a bit got lost off into the 0 bit. Then if and we can't really underflow here. I mean, you really can't underflow here. So subtract flow. So, yeah, this is getting weird. And so, like, with the carry flag, right, go to 0. So if it's not equal to 0, it is. Alright, so shifted to the left. Alright, so what happens? Holy crap. Someone's playing a gun game in my house. That is loud. Holy crap. So how are we going to detect whether or not a carry flag is set? Or what we can do is since we know it's this dot get register A, and we want the first bit, so we're going to do and x1, or just and 1 is equal.
Can you come here?
Man, my family is just really not nice. So I need to put parentheses around here to fix that, and so that should actually fix that. Because 1 is going to try to get the first bit, and that is before it is shifted, so if it's 1, then that is true, and if it's not, then that's false. So, yeah, that's how we're going to do the right way, and that is using F as well. That's using F, yes. This is such an interesting live stream because I'm super busy and I don't want to be super busy. Hold on. And where's this? There it is. Alright, so case of 0x 0f, that does not was out. And then we need to say this one is set to false, and then we need to break it up. And then we need to set the other ones set to true. So there we go. We have gotten those shifting instructions done. And we already did that, and now we need to rotate. So we're finally, actually, let's save the CB for later. Let's go to the jumping ones. Here's our jumping ones. And then this should be the last jumps, basically. So jump to address an end, and all that good stuff. Hello, Son Goku. I'm just kind of in the middle of fun with the family because they won't leave me alone. And I've told them that, and they still won't. So, anyways, let's continue on. So, we're going to be doing the jump instructions, which is how we do like loops and all that good stuff. So, where's this? Get register, set register, and right here is where we're going to do this. So public void jump, and jumping is only going to affect one instruction. It's only going to be one, and it's going to be in. So jump in, and it's just going to take this register. So I think we could just do set CPU dot set program counter to this dot get register and then in, and that's all we have to do. And that is actually really simple, and so let's add that in there. And since it's only one instruction, case 0x, what is this, C3. So C3 this dot jump, and then break. So we need to do the next one, which is jump conditionally, and so we have a couple conditions. We have jump if it's the zero flag is 0, that means there wasn't, the last instruction wasn't 0, and then jump if it was 0, and then jump if it was there was no carry, and then jump if there was a carry, as you can see right here. We don't, the only argument we need is whether the flags, and we actually have to, get register and set register here. The emulation is for the Game Boy, which is a really fun thing to do. Right now I'm just trying to get the boot up ROM working, which is right here, and then I have a few testing things right here. So I'm just going to finish up the opcodes today, and then probably start with the disassembler to actually help with the debugger. Because you can't, if you're going to do emulation, you're going to have some really good debugging stuff. So yeah, so we have CC, so we have this. I don't know if I want to set these as a register. I think what we can do is we can do what I was going to originally do and just have a switch statement in each function, because they're not really registers, they're really just flags. So jump conditionally, and then we need string flag. So switch for the flag. So if the case, I always hate how it does that. I guess that's how the syntax is, but I don't like that syntax, so I'll just do my own. So if the flag is not 0, then we're going to say well, we can just call it jump, basically. All right, so if CPU.get register psw.get flag psw register dot what is this, the zero flag, and since it's not, we need to say if there was no zero, then we're going to jump. And that is the basics of how we do this. So boom, boom, and boom, boom, boom. And so we have to have a zero flag, and then we have to have a not carry flag, and then we have to have a carry flag. And so we need to say if there was a zero, then we need to do this, and then if there's not a carry, and then if there is a carry, jump. So now we can actually add that in there. Where's that switched image? Here it is. So we have 4 of these, for each flag. We have C2, CA, D2, and DA. So we have case C2 for this dot jump conditionally, and then we need to put in not 0, and then break. And then we need to do this 3 more times for the other couple flags. So boom, boom, boom. We have the 0, we have the not carry, and then we have the carry. And then this is CA, and then this is D2, and this is DA. And I think that's right. And I opened up my Discord again, and I don't like that. So close window. So yeah, there we go. So that's basically how we jump. Are you doing this daily? I'm gonna try to do it as often as I can. I'm in the weekend, so I can do it daily, but then school's gonna start tomorrow, and I don't know if I'm gonna, be able to do it daily then. But am I gonna at least do it as much as often? Because this doesn't take as much effort as recording a video, because it's just, and I can also talk to you guys and live and actually have a some good community happening, if you call this a community. So we need to do this jump right here. Oh, we also have another conditional jump, but it's then we have restart, returns, all this. So returns, we'll get to that when we get to that. So now what we need to do is we need to do jump to HL. So let's do that. What is it called? Oh yeah, Slimy. So jump, where's my jump? I'm going to do the same here. I'm actually going to have the register, so string register. And then most of it's going to have in. So I'm just going to put the register in here. And then in all these ones, it's going to be in. Let's put all those in there. Boom, boom, and boom, that one, boom. And then up in this instruction, we need to put in. And since I like to reuse code, I'm going to put this jump function as HL. Where is this? E9? E9. So E9. This dot jump with whatever is at HL. So register HL and break. So that is how it's done. We got now jumping relative, and jumping relative is fun because we also have to mess with sign bytes here. So let's go down here and say public void jump relative, so jump r. And then it really doesn't matter here because okay, so we have jump relative. It's just gonna take the next byte as the signed byte, and then it's gonna do the conditional jumps. Okay, so yeah, we only need this. We don't need anything here. So I'm gonna do the next thing, and that's how we get assigned byte. Where's this? So this gets the next one, and it's assigned byte, so that'll work out pretty good. And we just need to say if, or not even if, we just need to say this dot or CPU. Oh crap! Now I'm in a menu. CPU dot get or set program counter to the program counter. So CPU dot get program counter plus s byte, because s byte can be positive or negative. And that's how we do relative jumps. And so jump relative right here, and it's only opcode 18. So up here in the switch statement, just add that in. Case 0x18, this dot jump relative break. And then similarly, I can't say that word at all. We have to do jump relative conditionals. So it's basically this. So I'm going to copy this, but for the relative jumps. And so just copy this, just put it here. I don't know, I think relative conditional. Alright, so this sucks. It just plain sucks. So anyways, I am just going to try to calm down and just code my way. So anyways, let's continue on. 20, 28, so 20, 28, 30, 38. And so that is our jump relative conditionals. I don't know, like jumping relative conditionally. I guess that's the right way of saying it. And then you have the next byte, so that works out. And then push address of next instruction onto stack, and then jump to the address. Alright, so that is pretty simple as well, because calling, like, this is basically how we do functions in assembly. So let's find that right here. Public void call, and then is there any like separate, like any way we can combine this? We have call conditional, and then we have restarts.